Whether you are watching live or archived, we need your help to keep fun going. You can subscribe to First Updates now on Twitch, give bits, or make a donation. If you're watching on YouTube, there's a link in the description on how you can help fun.
So moving on, we're going to go start with everyone's favorite build system, Tetrix. So the Tetrix kit comes in at $710 on the, excuse me one sec, $710 on the Tetrix website, but if you buy it in the storefront, that becomes subsidized to $529. The kit includes 850 plus pieces. It uses 4.7, I assume that's millimeter D shaft for rotary connections, and its main building use is the main structural components are channel. So Ethan, do you want to tell us about what is unique about this system?
So Tetrix channels are a little smaller. Their inside diameter is about 1.1 inches. I just measured that today. So they're smaller, easier to fit into the 18-inch sizing limit. Personally, I think they were great for the kind of inception period of FTC, where everything was just started out, and this was a new thing that Pisco kind of designed for this. And I think it worked out really well for the older era. But with newer FTC loads, with some of the crazy robots we see driving really, really fast, in my opinion, I think some of it's really become outdated, which kind of I'll talk a little bit more about at the end of this Tetrix portion. So up until this last year, it was the only option in the kit or into the storefront for First. They just recently added Rev, so First was really pushing Tetrix as their primary building system for 14 years, which is why it's really so widespread.
Yeah.
I feel like a lot of veterans teams had started out with the Tetrix building system, and a lot of veteran teams have a lot of it lying around, and many of them have phased out from it, but it's still a very usable kit. Like, we did the competition rescue 3 years ago using only a Tetrix robot, and we were able to qualify for the World Championship. So it's not impossible to build with, but it's also not the best.
Yeah, exactly.
Totally.
And like sometimes a lot of teams just don't have the funding to phase out an entire building system because it can get expensive. And you feel like you lose that investment that you had. I spent $1,000 on Tetrix parts. I don't really want to lose all that, but on the other end, it sometimes can be worth it depending.
I mean, going back to what we were talking about with modern robotics, if you're looking for a kit and there's some experienced teams nearby you, hit them up. We have, my team right now has just in a giant crate, all of our Tetrix channels, all of our Tetrix like bearings and hubs and everything that's like a bigger Tetrix part, just sitting in a bin. We're going to give it away at some point. We just haven't found a team to give it away to. We're trying to start some rookie teams in Chicago, so we'll probably hand them off to them. But we no longer have a need for it. So maybe teams like Recharged or Crack and Pinion or Wizards have parts that they could give away.
Yeah,
I'll say like our club has been around for I think about 7 years now, and we've amassed like thousands and thousands of Tetrix parts. And the years we've started to phase it out because we got a couple new kits from other companies. So we just have, I mean, they're really good for the rookie teams that we have at our school, but our team doesn't. We don't use them pretty much at all. Just a few parts in our robot.
Yeah.
So kind of building on that, what do you guys think an entry-level team how would this system work very well for them? Do you think it's an easy system for them to pick up, or is it one of the more challenging ones?
I think it's a good beginner system because like there aren't many options when building with Tetrix, and that can make it easier for rookie teams to get into it.
Yeah. I think it's a double-edged sword in my opinion, because it's really hard to use really competitively, but it's also easy to start out with and start learning into robotics.
I think it's a great tool for learning Tetrix. That's what I all started with when I was Tetrix. That was like sort of the first thing that I learned. So I think that was pretty good for that.
Yeah, I think it's a pretty good system for learning FTC. Personally, in my opinion, if you're going to master FTC, I would never use Tetrix, but I could see teams using Tetrix channels and other things kind of with hybrid bots, I would say. And I'm going to be talking more about custom and kind of a hybrid build system later on. So Ethan, how do you think, or Josh, how do you guys think that Tetrix can lend itself to really experienced teams and be used outside of just kind of the normal Tetrixes for rookies?
So Tetrix, it really doesn't blend terribly with other systems. There's always the slap a rev bar in between it and another piece of C channel, and that's a super easy way to connect and switch. You also have the pattern adapters that can switch from the kind of more Tetrix focused, it's like 0.62 inch whole pattern. You can get an adapter to switch from Actobotix whole pattern to Tetrix, which works fairly well. A lot of the small parts, people will just throw on a robot. I need a little bar right here, and a Tetrix bar works great. So
I would say it works excellently for prototyping. For doing like really, it works fairly well. Like you can throw together a drivetrain in like 10 minutes.
Yeah, definitely.
So how do you guys think the system lends itself to really more experienced or high-end teams? Do you guys have any opinions on that?
I think that Tetrix can be used by high-end teams. It is currently used by some high-end teams. Like I know Brainstormers use it primarily for their rescue robot 2 years ago. But I think that the motion components in Tetrix are sometimes hard to deal with. And it's just a lot easier to work with something else like Actobotix or Rev, which is going to have a much more reliable motion, and it's just a stronger building system. I think FTC was only supposed to be like 30-pound robots, but now these robots are hitting 42 pounds with that weight limit, and that's definitely going to push the Tetrix system to its max.
Yeah, definitely. I think that kind of goes into some of the drawbacks and faults that we have found with the system, which we'll get to in a sec. But I definitely think, going back to what I said earlier, Tetrix and all of these kits can really be used in a jumble to an extent, especially when you add some Andy Mark and other rev parts that I'll talk about later, because Tetrix has great components. It's just the system as a whole doesn't always stand alone. You got to add more.
Like I know one of the components that I really like to use from Tetrix is their servo mounts, because they're sturdy servo mounts and they do the job really well. And so since we have a bunch of Tetrix lying around, we just use those wherever we don't need like high load parts.
Yes. Yeah, I definitely have not had very many complaints with the Tetrix servo mounts, at least. Personally, using Tetrix effectively costs time. There are problems you run into. Like one of the biggest problems we found this year was all of the screw holes are slightly oversized to 632 bolts. So our entire drivetrain shifted and caused half of the drivetrain to buckle and warp. Let's see. It warped the axles and then ended up kind of causing a lot of binding and slowing down our drivetrain. So we fought that a lot. And there's a lot of little things that you have to fix with this building system that could be your time spent driver practice or working on autonomous.
Yeah. Some of the comments that we have in the chat from Ian 13752. Yeah, a lot of teams with other systems have at least one Tetrix part on their robot. Yeah, I totally agree with that. Most confusing thing with Tetrix is shaft versus motor hubs. I don't know if anyone wants to talk about that. I don't know if I totally understand what they're saying.
So they have different hubs for like motion, and the bore for a motor is different than the bore that you need for another type of motion for just the normal shafts that they have. And so a lot of teams try to put the shaft hubs, which are slightly smaller, onto motors, and that leads to a lot of problems because it's too small for the motor shaft. But I think also another one of the problems is just that the shafts are just not as strong as other things. Like they're stainless steel, but they're too skinny. And I know that vividly from Rescue, we bent up all of the shafts on our gearbox, and we had to replace them every competition.
Yeah.
I've also going back to the hub thing. I've seen team members put the larger hubs that are meant for the motors, smaller axles, because they just don't know any better, and it causes all sorts of issues because now the wheel is offset.
Mm-hmm. Yeah, Tetrix axles. So they're 4.7 millimeters. They're stainless steel, which sounds okay, but they're really, really not. So I could rant for as long as you give me about how terrible the 4.7 millimeter shaft ecosystem is for competitive FTC. It just bends. Like our drivetrain axles at this point are so bent, and we are never ever getting those out. Like I anticipate if we ever take that robot apart, we'll hacksaw the axles out because there's no way we can hammer them out of the bushings that are holding the whole drivetrain together. Which on the same side slows the robot down. It's
Yeah.
yeah. They 4.7 millimeter axles aren't really supported by the industry. Like you can't just go buy something for a 4.7 millimeter D shaft. Which really means you're limited to Tetrix hubs, which are only set screw hubs. So they're, weight-bearing set screws are really, really terrible. And they strip, and all of this is fine if you're a new team and your robot weighs 20 pounds. It's not going to cause an issue to you. But if you hit a 45-pound robot, you're going to fight it every match, and you're going to lose matches because of it.
Yeah. So moving down some of the other comments we have, again from Ian from 13752. They say that Tetrix is most compatible with Andy Mark stuff. Yeah, I agree. I'm going to talk about that in a little bit. We just had a comment that's from AMOTS 10030. You can get nubs from Andy Mark. Yep, I'm going to talk about that a little bit later. Tacklebat said all good teams still have a Tetrix part and a Lego, at least one. I've never had a Lego on my robot.
I would be lying if I said I haven't.
We definitely have.
I know Gluten Free they use Lego for not just one piece on it to say that they have Lego. They definitely use Lego.
Ethan, what was the team that used Lego as like a demo to figure out their lift or something? Was that Gluten Free?
I think it was.
Yeah.
Yeah, because they've come from 4 years of FLL.
Yeah.
A long time. They were amazing in FLL too. So it makes sense, the transition.
And from the chat, Modern Robotics is used by Gluten Free. Robo Greg said that 4.7 millimeter shafts is somewhat of marketing, and that they're actually 3/16. So maybe go find some 3/16 shafts. Interesting. I didn't know that. Someone did ask us, because FTC was originally mixed with VRC before parting, are there any teams who use VEX components on their bot?
There absolutely are. I've seen everything but from like Versa frame robots to just normal VRC frames. Those are pretty few and far between, and I can't tell you why.
So a lot of teams are switching over to using more VEX components. VEX has actually they created their own website to be able to help FTC teams know what parts to buy. And a lot of teams are buying VEX parts because they have the 3/8 inch hex shaft, which is very reliable for motion, and they also have 1/2 inch hex shaft. So a lot of teams are buying gearboxes to put on top of their motors or other things like that that are helping out.
This year for intake, we used VEX servo motors for intake. That worked really well.
The 393s, they count as a servo, but they're a lot faster and a lot torquier than most continuous rotation servos, and that allows us to get a lot of speed and power without having to sacrifice anything.
Yeah.
For sure.
I know that my team has used some VEX components, but mainly VEX Pro components. I don't know many teams that use like like VRC components because that uses 1/4 inch
Square shaft,
which is kind of weird, random.
Yeah.
It's whatever.
Coming from experience, we used to have like 12 Vex kits, so I've used Vex a lot, and I hate square shaft. So I doubt anyone would want to use that in an FTC bot unless that's all you had.
The way that we got around that is just by 3D printing. And we'll probably go into this a little bit more later when we get to the custom stuff. But 3D printing is a great way to adapt between the different systems. So we 3D printed a square bore, and we were able to put a square shaft through that and convert it to the 393 motors. And then on the end of that, we put an Actibotics pattern. That way we could have an Actibotics pattern coming from a Vex motor.
Yeah, it's a really great solution to that problem. I'm going to kind of wrap up our Tetrix talk by doing kind of a rapid fire. If you decide to go with Tetrix or you're kind of locked into that ecosystem, here's some things I've learned with 3.5 years of Tetrix experience to make it a little more competitive. So the channel can be bendy. So they've recently rolled out some gussets, which are made for Tetrix, and they're awesome. I love those gussets. And use a lot of the inside channel end caps. Those really help strengthen the channel and are pretty useful mounting stuff too. Let me see. The 4.7 millimeter axle interface, or 3/16, can be an issue, but you can actually work your way around it with some clever machining or 3D printing. So what I've seen a couple teams do is they'll 3D print a bearing block, which fits inside of a piece of Tetrix channel and uses a 1/4 inch inside diameter bearing, and basically can adapt Tetrix into a 1/4 inch D-shaft interface, which doesn't bend nearly as much and allows you to use bearings. So if you can, and if you want to go that route, I would definitely recommend that for a drivetrain. But Tetrix in general for drivetrains is really, really bad.